In January 2013, physicists in Munich created something that should not exist: a temperature below absolute zero. Not a rounding error, an actual negative Kelvin gas, simultaneously colder than nothing and hotter than any fire ever recorded. And at that temperature, the laws of thermodynamics don't break, they invert. By the end of this video, you'll know what lives at every level of the temperature scale, including the ones nobody told you were real. By minute 12, the mirror that links the hottest and coldest things humans have ever made will finally make sense. Temperature at its core is motion. Atoms vibrate, collide, and spin, and the faster they move, the hotter the substance they form. Absolute zero, minus 273.15 degrees Celsius, is the theoretical floor, the point where all atomic motion ceases, where there is simply nothing left to slow down. For over a century, science treated this as the end of the road. But absolute zero is not the end of the road, it is the middle of it. Before that inversion is confronted directly, consider the scale in its full strangeness. Imagine a vertical ladder stretching from a basement so deep it curves back through the floor, up through every temperature humans have ever survived, measured, or theorized, from 38 trillionths of a degree above nothing, all the way to 1,000,000,000,000 times the surface of the sun. A human figure standing on that ladder is invisible, a dust mote on a skyscraper. The bottom rung of the known ladder, the coldest temperature ever recorded anywhere, was set not in a nebula or a neutron star, but in a laboratory in 2021. A team using matter-wave lensing on rubidium Bose-Einstein condensates achieved 38 picokelvin, 38 trillionths of a degree above absolute zero. That temperature has never existed anywhere in the natural universe. Humans made it. Once. To feel what 38 picokelvin means, strip a rubidium atom down to its behavior. At room temperature, atoms jostle at hundreds of meters per second. Cool them with lasers, trap them in magnetic fields, and they slow. At 38 picokelvin, the atoms have nearly surrendered all individual identity. They stop behaving like particles and begin behaving like a single quantum object, a Bose-Einstein condensate, a ghost of matter rather than matter itself. Bose-Einstein condensates were predicted by Albert Einstein and Satyendra Nath Bose in 1924, and first created in a laboratory in 1995 by Eric Cornell and Carl Wieman at JILA in Boulder, Colorado. The Nobel Prize followed 6 years later. In a condensate, thousands of atoms occupy the same quantum state simultaneously, as if they have dissolved into one another, individual identities erased by extreme cold into a single, coherent quantum whisper. And yet 38 picokelvin is still above zero. What lives below zero is something else entirely. The negative Kelvin gas does not behave the way the name implies. Hold that thought. To understand negative temperature, the concept of temperature itself must be rebuilt from the foundation. Temperature is not simply how fast atoms move, that is a shortcut. More precisely, temperature describes the relationship between energy and entropy, how many new arrangements a system can access as it gains energy. When a system has used up all its possible arrangements, when adding more energy produces no new disorder, temperature flips sign. Picture a ladder of energy levels inside a quantum system. Normally, most atoms crowd the lower rungs with fewer at the top, a thermal distribution. Heat the system and atoms climb. But in 2013, the Munich team at LMU and the Max Planck Institute of Quantum Optics loaded a gas of potassium atoms into an optical lattice, a grid of laser beams, and flipped the distribution entirely. More atoms occupied the upper rungs than the lower. The system's entropy slope reversed. Temperature became negative. What does a negative Kelvin gas feel like to the universe around it? Stranger than almost anything that follows on this scale. When a negative temperature system releases heat into a positive temperature environment, it does not simply warm the surroundings, it pulls the thermodynamic arrow backward. The Munich gas was simultaneously below absolute zero in mathematical terms and hotter than any positive temperature in energetic terms. The thermometer scale does not stop at infinity. It loops. Here is the number that reframes everything. Negative Kelvin is not -1 degree warmer than absolute zero. On the thermodynamic scale, negative temperatures are hotter than positive infinity. A gas at -10 nanokelvin is more energetically extreme than a gas at 10 trillion degrees positive. The Munich team published this in Science on January 4, 2013, and the physics community spent weeks debating whether the paper was correct. It was. The consequences for engineering are quietly extraordinary. At negative absolute temperature, a heat engine, the abstract machine that underlies every turbine, every combustion process, every power plant on Earth, can theoretically exceed 100% thermodynamic efficiency. Not by cheating conservation of energy, but because the classical Carnot limit, which caps efficiency below 100%, assumes the cold reservoir has a positive temperature. When it does not, the math changes. The ceiling lifts. The engine outputs more work than any positive temperature machine could produce from the same energy budget. No such engine has been built, but the Munich result proved the physical state that would power it is real. Now the scale reverses direction. Climb upward from the quantum basement, because the strangest stops are not only at the extremes. Leaving the sub-picokelvin tier and ascending into single-digit Kelvin territory, one of the most counterintuitive objects in the observable universe comes into view, not in a laboratory, but floating 5,000 light-years away in the constellation Centaurus. The Boomerang Nebula, a cloud of gas and dust roughly 1 light-year across, expanding outward at 164 kilometers per second. Its temperature, approximately 1 Kelvin. 1 Kelvin is colder than the cosmic microwave background, the afterglow heat left over from the Big Bang, which permeates all of known space at 2.725 Kelvin. Every natural object in the universe bathes in that radiation and equilibrates toward it over time. Every natural object, except the Boomerang Nebula. It is the only known natural region in the universe colder than the ambient temperature of space itself. It does not emit CMB radiation. It absorbs it. The reason the Boomerang Nebula exists at 1 Kelvin is, by any measure, an act of stellar self-destruction on a scale that strains comprehension. The dying star at its center is shedding mass at a rate 100 billion times faster than the sun's own solar wind, according to NASA astronomer Dr. Raghvendra Sahai. As that gas expands violently outward, it undergoes adiabatic cooling. The same physics that makes an aerosol can feel cold when sprayed, but scaled to the output of an entire dying star. Pause on that number. The sun loses approximately 1 million tons of material per second through its solar wind. The Boomerang Nebula's central star is losing 100 billion times that amount. The star is not slowly dying. It is hemorrhaging itself into the void so fast that the outrushing gas cools below the temperature of the universe's own background radiation. It is a refrigerator powered by catastrophic stellar collapse, and it is the coldest natural object ever measured. Move upward now, leaving the single-digit Kelvin tier. At 4.2 Kelvin, liquid helium stops flowing with any resistance at all. Below this temperature, helium becomes a superfluid, a liquid with exactly zero viscosity. Pour it into a container and it crawls up the walls and out over the rim of its own accord, defying gravity through quantum coherence. The effect was first observed by Pyotr Kapitsa in Moscow in 1937, earning him a Nobel Prize 40 years later, one of science's longer delays. At 77 Kelvin, -196 Celsius, liquid nitrogen becomes the workhorse of cryogenic preservation. Human cells frozen at this temperature and revived decades later still function. Biological samples, genetic material, reproductive cells, all suspended in time at 77 Kelvin. The nitrogen itself becomes a pale, faintly steaming liquid that looks unremarkable beside what it actually accomplishes, the temporary pause of biological time. The freezing point of mercury sits at 234 Kelvin, minus 39 Celsius. Below this temperature, the liquid metal that filled thermometers for centuries solidifies. It can be hammered like tin. This was the lower bound of Fahrenheit's original thermometer scale, the coldest thing Gabriel Fahrenheit could reliably reproduce in his Amsterdam laboratory in 1714. The entire Fahrenheit system, still used by one nation of 330 million people, is anchored to the freezing point of a metal. Every civilization that has ever existed has lived and died within a thin band of about 60 Kelvin on a scale that spans trillions. That is the next stop. The habitable band for liquid water, 273 Kelvin to 373 Kelvin, 0 to 100 Celsius, is the thermal corridor that produced every organism ever known to science. In that 100-degree window, photosynthesis, digestion, nerve conduction, plate tectonics as a climate regulator, ocean currents, hurricane formation, and the full recorded sweep of human history. All of it, 100 Kelvin wide. On a scale measured in trillions. Climb above the boiling point of water, and the human body's operational range ends quickly. At 310 Kelvin, the interior of a healthy human body maintains itself with extraordinary precision. A variation of more than 4 Kelvin in either direction begins shutting down enzymatic processes. The body is a machine calibrated to a specific address on the temperature scale, and it holds that address with remarkable stubbornness. At roughly 5,778 Kelvin, the surface of the sun glows white with the particular intensity that humans perceive as sunlight. But the surface is a footnote. The corona, the sun's outer atmosphere, reaches 1 to 3 million Kelvin, and no one fully understands why. The corona heating problem has remained unsolved for over 80 years. Energy moves outward from the solar core, but the outermost layer is far hotter than the surface below it, which appears to violate intuition about how heat flows. It does not violate thermodynamics, but the mechanism is still contested. Now, the scale is about to break open. What comes next makes everything so far look like a warm afternoon. But first, the mirror needs to be explained, because the hottest thing ever made and the coldest thing ever made are the same thing. To understand the mirror, the concept of viscosity must be briefly examined. Viscosity is resistance to flow. Honey is more viscous than water, water more than air. At human scales, colder substances generally become more viscous. Liquids thicken, gases slow. The assumption is that heating a substance always moves it toward less ordered flow. That assumption is not universally correct, and at the extremes of the temperature scale, it fails in a way that is genuinely startling. At temperatures near absolute zero, certain quantum fluids, including ultra-cold fermionic atom gases, flow with nearly zero viscosity. The atoms are so deeply entangled by quantum mechanics that they move collectively without friction. Physicists at MIT and other institutions have produced these near-perfect quantum liquids in traps, observing that the ratio of viscosity to entropy density in these cold gases approaches a theoretical minimum, a value predicted by string theory, of all things. That theoretical minimum, called the KSS bound after Kelvin, Sun, and Starinets, who derived it from holographic duality in 2005, sets a floor on how frictionless any fluid can be. In principle, it should appear in systems of extreme quantum coherence. Cold atom traps approach it. This is surprising but perhaps not shocking, given the quantum nature of those systems. What is shocking is where else the KSS bound appears, and that requires a gold nucleus traveling at nearly the speed of light. The relativistic heavy ion collider at Brookhaven National Laboratory in Upton, New York, was designed to recreate the conditions of the universe approximately 1 microsecond after the Big Bang. Gold nuclei, stripped of their electrons, dense with protons and neutrons, are accelerated in opposite directions around a 3.8-kilometer ring until they reach 99.995% of the speed of light. Then they collide. What happens in the next fraction of a second breaks every category of hot. The temperature reached inside a RHIC gold-gold collision is 7.2 trillion degrees Kelvin. That is the Guinness World Record for the hottest human-made temperature, but the record is almost beside the point. At 7.2 trillion degrees, protons and neutrons, the particles that make up every atomic nucleus, dissolve. Their constituent quarks and gluons, normally confined inside hadrons by the strong nuclear force, break free and form a new state of matter, the quark-gluon plasma. This is the state the universe existed in during its first microsecond of life, before the strong force condensed matter into the particles now familiar from chemistry textbooks. The quark-gluon plasma at RHIC was expected to behave like a hot gas, particles streaming past one another freely, weakly interacting, the textbook prediction from quantum chromodynamics. It did not. Instead, it flowed almost without friction. Its viscosity-to-entropy ratio fell to near the KSS bound, the same minimum value observed in ultra-cold quantum atom traps near absolute zero. RHIC physicist Stephen Victor confirmed the parallel directly. The hottest substance ever created by humans and the coldest substances ever created by humans are both near-perfect liquids, for reasons rooted in the same mathematical structure. The mirror is not a metaphor. It is a precise quantitative correspondence between the thermodynamic behavior of a gold-ion fireball at 7.2 trillion degrees and a cloud of fermionic atoms at a few hundred nanokelvin. The two systems are separated by 22 orders of magnitude on the temperature scale and connected by a single theoretical framework derived, improbably, from a 10-dimensional string theory model of black holes. Physics did not expect this. It found it anyway. Above 7.2 trillion degrees, the universe is no longer populated by atoms, nuclei, or even free quarks in any stable configuration. The thermal energy exceeds the mass energy of the particles themselves and begins producing matter-antimatter pairs spontaneously from the vacuum, photons converting into electron-positron pairs and back, a churning quantum foam that erases the distinction between radiation and matter. Temperature here is not just a measurement of motion. It is a measure of how much matter the energy field can temporarily crystallize. Ascending further still, past 10 quadrillion Kelvin, past the electroweak unification temperature of approximately 2 quadrillion Kelvin, where the electromagnetic force and the weak nuclear force merge into one, the four fundamental forces of nature begin to converge. Each unification threshold is a phase transition in the structure of the universe itself, a temperature at which the laws that govern particle interactions change form. The universe passed through each of these thresholds in its first second of existence. At roughly 10 to the power of 28 Kelvin, the gut scale, where grand unified theories predict the strong force rejoins the electroweak force. The universe was perhaps 10 to the minus 36 seconds old. There is no experimental data at this temperature. Particle accelerators that could probe this scale would need to be larger than the solar system, built from materials that do not yet exist, powered by energies not available in the observable universe. The gut scale is known only through the mathematics of symmetry. At the absolute ceiling of the known temperature scale sits the Planck temperature, 1.416 times 10 to the power of 32 Kelvin. This is not simply a very large number. It is the temperature at which quantum gravitational effects become dominant over all other physics. Below this temperature, general relativity and quantum mechanics can, with effort, be applied separately. At the Planck temperature, both break down simultaneously. The tools physicists use to describe reality stop working. What exists at or above this temperature is not currently describable by any known theory. The Planck temperature is the ceiling, but the floor, remember what was said in Scene 1, is not absolute zero. The full temperature axis, seen now from sufficient altitude, reveals its true shape. Positive temperatures run from near absolute zero up through the Planck scale. Then, At the mathematical limit of positive infinity, the scale does not end. It wraps. Negative temperatures in the thermodynamic sense are hotter than any positive temperature. The Munich potassium gas at negative nanokelvin sits, in terms of energy distribution, above the Planck temperature itself, on the far side of the thermodynamic circle. This means the ladder that seemed to stretch from a basement to an infinite sky is actually a loop. The coldest achievable positive temperature, 38 picokelvin, reached in 2021, sits near the bottom of the positive arc. The Boomerang Nebula, the coldest natural object in the universe, sits at 1 Kelvin, also near the bottom. The Brookhaven gold plasma sits near the top of the positive arc at 7.2 trillion degrees, close to but below the Planck scale. And then, past the top, the Munich gas wraps around to the other side of the loop, technically hotter than everything, labeled with a minus sign. The Aalto University rhodium experiment, which cooled a solid object to 1/10,000,000th of a Kelvin, 0.0000000001 K, the coldest solid ever made, sits between the BEC records and the Boomerang Nebula on the positive arc. Every cold record in human history is clustered in a vanishingly thin band near the bottom of a circle. Every hot record spirals toward the top. And one experiment in Munich reached around the back of the circle entirely and touched the other side. The traveler who began this journey at 38 picokelvin, a temperature that has never occurred naturally anywhere in the universe, has now passed through liquid helium and nitrogen, through the freezing point of mercury, through the precise thermal corridor where life is possible, through the surface of the sun and its mysterious overheated corona, through the quark-gluon plasma at 7.2 trillion degrees, through the electroweak and gut unification thresholds, up to the Planck ceiling, and then around, through the back of the scale, to land at a negative Kelvin gas in Munich. In January 2013, physicists proved the thermometer wraps. From 38 picokelvin, the coldest trapped atoms ever measured, up through the Boomerang Nebula's 1 Kelvin, through every fire and star, through Brookhaven's gold soup, all the way to the Planck temperature where physics dissolves. That is the full scale. The Munich gas sits at both ends simultaneously, the mirror fluid paradox, coldest by entropy, hottest by energy. Temperature has no floor, no ceiling, only a seam. Which stop surprised you most?